Hello and welcome to Aviation Map Reading Part 3. Today we're going to talk about the map recce or the map reconnaissance and map preparation. So before entering your intended area of operations, it's important to conduct a map reconnaissance to gain enhanced situational awareness. So what you need to do is you look for key features that can help you with your task, whatever that might be. So let's have a look at some map legend information and do a tabletop map recce. Now a tabletop map recce basically means you just put the map on a table and have a look at it. So there's nothing special about it. So here we find some information that you'll find in the margin, some of the marginalia. And if you have a look at some of the items here, depending on what job you're doing, what task you're undertaking, some of this information could be quite pertinent to you. So let's have a look up the top here. So we have up here we have a school, a police station, a hospital, and a fire station. So why is it important to know those things? Well, let's say for example you are conducting support for the emergency services, maybe firefighting or something similar. Knowing where a school is can be quite important because let's say you're working around a small town, everyone in the town will know where the school is. So if you need to meet someone, you can say, I'll meet you at the school at such and such a town. The other thing about schools is they normally have football fields or playgrounds or something quite large where a helicopter can land. So knowing where a school is means you know a landmark and know a feature where in the town, and also somewhere where you're going to be able to put the aircraft down for a landing to pick someone up, etc. Same with the police station. In the event of emergency, it's handy to know where the police station is. You may need to pick up a copper to take them out to an accident site, or they might be overseeing an evacuation or something similar. Hospital, well, that's pretty obvious. It's good to know where the hospitals are, and same with the fire stations. Over here, SES, you could actually be working for the SES, so you need to know where the local SES station is, ambulance station as well. This line here is a fence line, so on some cadastral maps and topo maps, that will be a good feature to know. Pipelines are good for aerial navigation, and of course over here it shows that the pipeline has gone underground. Now this symbol here is one used on many topo maps to denote a power transmission line. And it says here with the pylons. Now the pylons usually aren't indicative of where the pylons actually are on the ground. This is just a symbol. So knowing where a power line is important, especially if you're going to be conducting low flying operations. A trig station. Normally with a trig station you'll see something on top of some high ground. So you may see a can of rocks, or usually it's a pole with like a sort of reflective type device on it. Spot elevations, they really don't mean anything to you. So if you just want to know what the terrain elevation is in the area, that will tell you. Certain landmarks, ruins, old buildings, cemeteries, etc. A quarry. Silos are good as well. Silos, especially on railway lines, are a great landmark to use for navigation. And then of course things like mines and helipads, always good information to know. If you're conducting support to, say, firefighting operations, it's good to know where the local water sources are so that you can refill up your fire buckets or your belly tanks. So things like rivers and creeks, drains, etc., dams. Dams are good landmark features. This one here is a weir with a road across the top. So if you're doing some navigation, it's a good feature. Those things usually aren't removed easily, so they could be standing there for decades. Natural items like falls and rapids, yeah, they're good to know. A lock, again, whilst it's not a good idea to use man-made features, some of these man-made features you can be relatively sure will stay there for a long time. Whereas things like rapids and things, well, one rapid looks like another rapid to me, so that may be a good clue along a river line as a key to navigation, but then I may get it mixed up with another set of rapids, maybe a kilometre down the track. So just be aware that map recce's are more for situational awareness, and sometimes you have to be very judicious as to what items you use for, say, navigational points. So continuing on with the map recce, we look at power lines. Power lines are very important for pilots because we don't want to fly into them. But they're also very good for navigation. So on the three key aviation charts, you'll see different symbology for power lines, which is a little bit silly if you ask me. But on transmission lines are shown on WACS, the 1:1 million scale charts, as wavy blue lines with T symbols. They look like that. On VNCs, they also have black wavy lines with T symbols like that. And on VTCs, they're black lines, but they're black straight lines with T symbols like that. Now, also, you may have noticed from one of the previous parts that there was some transmission lines shown, and they didn't have the T. So you have to be careful with all this symbology, and that's why it's important to do the map reading and know what you're looking for. So before you get into your aircraft, you should prepare your map. So get the map ready for use in the cockpit, because remember, when you're in the cockpit, you're strapped into a harness. Your bag may actually be on the seat behind you and may not necessarily be easy to get to. Also, you don't want a large map in the cockpit because it's very hard to fold it. So try and get your map ready to go. Fold it in such a way so that the area that you're going to be operating in is a nice, small, manageable square or rectangle that's easily available to you and easy to stow. So fold it into a manageable size. A good idea, because you're folding it, you may not necessarily have visibility on the eastings and the northings, as in their numbers, those UTM numbers. So it's a good idea to draw them in and then highlight them. I'll show you that in a diagram soon. When you're looking at the contour lines, you may recall from the previous videos the contour lines with index lines. Well, sometimes it's a good idea to actually draw those in. So you have the contour index lines, but get a pencil and actually outline them, and it will emphasize the terrain. I'll show you in the next slide what I mean by that. And then also draw in your track and any rough directions and distances if required. What you're trying to do as you're looking at the map is you're trying to get a feel for the terrain. So as you look at it, you think, well, where's the high ground? It's to my north. I've got a river to my south. So you're getting a bit of a feel for what you're expecting to see when you're in the aircraft. Now have a look at this map here. It's actually from a place in Tasmania. Now study the map for a few seconds and see what you can glean from it. And then we'll also prepare the map. So let's prepare the map. First things first. Here I am highlighting where my eastings are. On the left there, you can see that I've got the northings. That's no problem. I've got access to the northings, so I know what they are. But I don't have any access to the eastings, except for, say, this line right here. Shows me that I'm on the 20-kilometre line. So I've actually gone through and written them down, and each easting, and then highlighted them so I can readily find them in a bouncing cockpit. Here I've used a marker to draw in the index lines. So the index lines are already there on the map. Here's some examples of index lines. There's the 800-metre index line, the 1,000-metre index line. I've just carried that on. So here's the 1,200-metre index line and the 1,600-metre, the 1,400-metre index line, and same over here. And by doing that, you get a bit of an idea of what the terrain's going to look like. So here we have a conical feature, Mount Byron. And then down here we have a bit of a saddle. And then we have Mount Cuvier over here and Mount Manfred up to the north. Over here we have this ridge line and looks like Beaumont's Lookout. And it's quite long and elongated. But notice here you have a bit of a saddle, and it's Byron Gap. So I'm getting an idea of this long ridge line, bit of a saddle, then a conical feature, another saddle, and then Mount Cuvier. So I'm getting an idea of what the terrain looks like. And to the north, I've got this shallow spur line with cliffs on the northern face. I have this re-entrant with a creek line going down to Narcissus Bay. So relatively flat ground down here. And then to the south, I've got some bit of high ground, a little bit of a ridge line. Notice the hatchering, the tinting there that shows that there's a bit of high ground. So there's a high feature, there's another high feature, and there's another high feature. And then we've got this low feature down here, which is exaggerated by the fact that there is a blue lake, a blue feature, a lake. So obviously that's going to be the lowest part of the terrain around here. And I've got higher ground down to the south. So there's high ground, very low ground with a lake in it. I've got a significant ridge line with some quite remarkable features there, obvious features. And then coming down to a re-entrant and a spur line, another re-entrant or a creek line, and then some high ground to the north. So I'm getting a bit of a feel that the terrain here is more or less east-west. This here is exactly the same terrain from Google Earth shot, so it's an aerial photograph. It's a bit of a photo mosaic, and that's why over here it looks a little different. You can see when they took the photographs for this satellite run here, there's a bit of cloud cover that maybe they couldn't get any good cloud cover over a protracted period, so they've just gone with the least disruptive image. So let's have a look at the items that we looked at before. So we have this low ground that we saw before with the what I call the blue feature, this lake down the low ground. There's a bit of ridge line here, and here is that long east-west ridge line. There's that gap, that Byron gap, and there's Mount Byron right there. So there's a conical feature. There's another sort of saddle, and comes up here, and it's slightly hidden in the cloud there. There's Mount Cuvier, and up here is Mount Manfred, with that long low spur line leading down to Narcissus Bay. So I can get an idea of what it looks like. Now that's from an aerial photograph looking straight down. That's a vertical photograph. But one of the aspects of Google, which is really good, is that you can actually take an oblique shot and get an idea of what it looks like obliquely. So let's have a look at that. So let's look at those features we saw before from an oblique angle. We have Petrarch Lake down here in the low ground, and those other small little lakes that you may have seen on the map recce. We have the east-west ridge line, so that long ridge line. There's the Byron Gap, and there's Mount Byron, another saddle, and there's Mount Cuvier. Here's Mount Manfred up here with that long low spur line leading down to Narcissus Lake or Narcissus Bay, and you've got that re-entrant down in between the two. So if I'm flying around this area, maybe I'm doing support to the firefighting, and there's a fire along this high ground here, I know that I'm going to get water there and water over there, and I get an idea of if there's a lot of smoke in the area. This feature here may be quite obvious, and if I study it closely, I can maybe make it out in poor visibility or a long distance, so I know where I am. Lake behind me, that feature there is going to be Mount Byron, so I get an idea there's high ground to my right and high ground to my left if I'm flying in that direction. That's it again. You can see that angle I was showing you before. There's Mount Petrarch there, Lake Petrarch. There's Mount Byron, Byron Gap, and there's that long ridge line. So you see, just by getting a feel for the terrain and using whatever tools you can, the map, Google Earth, you get an idea of what you're to expect when you get out there, and then it's not a surprise when you do arrive. And that's the terrain again, just for comparison. Another thing you should be looking at is trying to figure out your scale trick. So you could be using a 1 to 100,000 scale map, or a 1 to 50,000 scale map, or a 1 to 25,000 scale map if you're looking at things in finer detail. Here's a couple of things that you can do to help with your navigation. Check the scale of the map and figure out what you can use as a rule. A rule is a straight edge or something similar. A great thing to use is a pencil. If you're marking on the map, a pencil is a great thing to use as a rule. So what you can do is you grab your pencil and you draw lines on it. Now let's say, for example, you're using a 1 to 100,000 scale map. So if you draw your lines on it 3 centimeters apart, on a 1 to 100,000 scale map, 3 centimeters on the pencil, when put on the map, will indicate 3 kilometers. Because remember, on that 100,000 scale map, 1 centimeter on the map is equal to 1 kilometer on the ground. So 3 centimeters obviously equals 3 kilometers, which is 1.6 nautical miles. Now, if you're flying at 100 knots, you're traveling at the equivalent of 185 kilometers per hour. And seeing as how there are 60 minutes in an hour, if I divide 185 kilometers traveled in that 1 hour by 60, that will tell me how many kilometers I will travel in 1 minute. Well, as it turns out, in 1 minute, I'm going to be traveling 3 kilometers. So 185 divided by 60 is just a little over 3. So those lines on my pencil will tell me how far I am traveling in kilometers, 3 kilometers per line, or how many minutes it's going to take me to travel that distance, which is 1 minute. So that line on my pencil is a 3 kilometer line or a 1 minute line. There you go, 1 minute lines as well as 3 kilometer lines. So you can use that pencil now to get a rough estimate of how long it will take you to transit an area. So grab your pencil, chuck it on the map, and then you count the number of lines on your pencil. It goes 1, 2, 3, 4. All right, it's going to take me 4 minutes to get there. It's about 12 kilometers from point A to point B. It's great for pilots because they can do a quick calculation of how much fuel they'll burn tracking along there, and they'll be able to use it for enhanced situational awareness. Now, in this this map here, let's have a look. So Mount Byron, from there to there, is roughly 1 kilometre. Now, if we're travelling at 100 knots and we're travelling along this ridgeline here, it's going to take me about 20 seconds to go from there to there. Remember, we travel 3 kilometres in 1 minute when travelling at 100 knots. So therefore, 1 kilometre, which is roughly that distance there, will take me 20 seconds to pass. So it's a good way to sort of do a bit of a rough check. Here I am passing Mount Byron, should be about 20 seconds. In 20 seconds I should be passing over a track which I may or may not see, but I'll definitely be tracking over this re-entrant. So as I'm flying along here, I can start counting 1, 2, 3, etc. 17, 18, 19, 20. Yep, there's the creek line. Oh, there's the track. I've seen it. So it gives you an idea on how you're tracking over the ground. Good for situational awareness. A mud map. Now, a mud map is a term they use, especially in the military. They used to have a technique out in the field where you would make like a 3D terrain model of the local terrain, just using mud and rocks and sticks and things like that. And they called it a mud map. And that way everyone can gather around it, and you can use it for situational awareness. You say, here is the high ground. You can see the high ground over to the west there. Here is a blue feature there, the river, and you can see the riverbank to the north. So you get a bit of orientation of your area on the ground compared to this little 3D terrain map that you make out of mud and sticks, etc. So they've used the term to also describe little sketches, small sketches that you can do, and so you can use it for briefing, or you can just use it for self-briefing or getting situational awareness. So a mud map is also a small sketch of the route that you want to take, and it's got important information on it. Such things as headings and distances that you need to track. Like, say, for example, you might be doing a navigational exercise. You've got 6 waypoints. You can you can draw in the waypoints and the distances and times that you would expect to have to fly at a certain speed. Now, remember the last slide I said 100 knots is 3 kilometers a minute. Well, you might have to travel 6 kilometers from point A to point B. You know it's going to take you 2 minutes to do it, and you have to do it at a heading of 090 or a track of 090. So if you fly 090 and start your stopwatch, as soon as 120 seconds pass, you should be at your new waypoint. Other things you can put on your mud map are things like frequencies and call signs that you don't have to keep on referring to other documents. The mud map is something that you might just strap to your leg on your kneeboard, or have it handy on a folder or something similar. Other things you'd do on your mud map, put in the large features, things that you can easily recognize, transmission lines, large mountains, rivers, and those sort of things. And also allow yourself areas to write on the mud map so that you can scribble in some notes as you're flying. Just by drawing a mud map is very good as a part of the map recce and helps with situational awareness. So take the 5 or 10 minutes to sit down before you go out on your flight and draw a bit of a mud map of where you think you need to be, and then you can cross-reference it. And then in the aircraft, that's something that you can just refer to ensure that you are tracking where you expect to track. And as I said before, mud maps are fantastic for briefing other people. I'll give you an example of using a mud map. So here is a VNC of the Tyree area. Now let's say that we're going to be operating in this area here north of Tyree. So there's the Tyree airfield, there's Tyree Township with the, what river is that? I have no idea what river. There we go. The Manning River. So there's the Manning River going through Tyree, and I want to fly out in this area up here. Okay, so what I've done here is I've created a mud map of Tyree over here on my kneeboard. We've got YTRE, which is the abbreviation for Tyree. I have the Manning River. with this island that it forms just south of the airfield. I've got the Tyree township, and that equates to here, the airfield, the Manning River, and that island that it forms there, and the Tyree township. Now in this case here, what I want to do is I want to track around this track here. So I've drawn it on my mud map, and I've drawn some large features as I showed you, the township, the river. I've also done the state forest, and I've done my tracks with distances and headings. And in this case here, I've decided to use kilometers rather than nautical miles. So I know that if I track along here out of Tyree, the river should be behind me, Tyree township should be on my left, and about, that's the 10k league, I'd say about the 2k mark, I should be crossing over the boundary of the state forest, which may be quite evident from the air. So in 10 kilometers on a track of 330, I should hit waypoint A. Now knowing that at 100 knots I'm traveling at 3 kilometers a minute, it's going to take me 3 minutes and 20 seconds to reach that waypoint. Once I hit that waypoint, I may be able to see it on the ground. I'm doing a right-hand turn onto a track of 020 for 8 kilometers. So again, at 3 kilometers a minute, or 9 kilometers is going to take me 3 minutes. So it's going to be 20 seconds less than 3 minutes. So 2 minutes and 40 seconds, I should hit waypoint B, which is just past the boundary of the state forest. So as I head over the boundary of the state forest, I'll be checking my watch, and sure enough, I'm on track, on time, and there's my waypoint. When I hit my waypoint, it's a right turn onto 070 for 5 kilometers. So that's 1 minute and 40 seconds, etc. and so forth. Now, by having this big feature down here, I know that if I miss this last leg, let's say for example, instead of going 160, I go 120. I start tracking out here. I don't hit my waypoint, but on time, I decide to change my direction, as if I'm heading back to Tyree, and I track 210. I'm going to be tracking 210 from here. And if I keep on going, I'm going to miss Tyree, but I'm going to hit the river. But because I've got this mud map, and because I've already done a recce of the map, I know that if I hit the river and I don't see that island, well then I'm obviously nowhere near Tyree. I'm going to be somewhere up here. If I'm over this direction, I know that it's going to be near the township. So I hit the river, I think, okay, I'm downstream of where Tyree is. I just turn right and follow the stream up to Tyree, and there it is. So a mud map helps you with good situational awareness. Down here I've got some frequencies, the fire CTAF, the Common Traffic Advisory Frequency 123.45, Tyree CTAF 118.1, and Brisbane Centre on 120.55. So I don't have to refer to my map, and I don't have to pull my en route supplement out, my reference books. Everything there is on my mud map. So as we said, if at 100 knots you travel 3 kilometers per minute, or 1 grid square every 20 seconds on a 1 to 100,000 topo map, that's a handy thing to know. Obviously, if you're using a different topo map or a WAC, it's going to be different. So you need to do the conversions, and I can show you that in class. Another thing to do is to get to know how the aircraft GPS displays information. Every GPS should show you things like present position. It should show you in either latitude and longitude or UTM or MGRS, depending on what settings you use. So ask the pilot, how does your GPS work, and ask him to show you where present position is. In most aircraft, you should actually have your own GPS available to you. So learn how to use the GPS, and also learn how to use the compass, or where the compass is. The compass is known as an HSI, a Horizontal Situation Indicator, and that will give you more information on how to orient your map. So if you're tracking north, then north should be the top part of your map. If you're tracking east, then turn it around so east is at the top part of your map. It helps you with orientation. And finally, ask the pilot. That's what he or she is there for. Their job is to fly the aircraft safely and efficiently and do everything in his or her power to make sure that you get the job done. So if you need to, ask the pilot for some help, and he or she will help you. And if they don't know, well, then maybe they should hand in their wings. So in conclusion, you've got to remember this. When you're operating in an aircraft, it's going to increase your stress levels. You'll have difficulty in some cases to reach your equipment. It may be strapped into a nav bag, and it might be strapped onto the back seat, or the map might be too large to have all of it available, or whatever the restriction may be. Also, there's going to be a lot of noise and there's going to be vibration, which makes it difficult to do work, and it just increases your stress levels. And finally, speed. On the ground, you'll be traveling at 60 or 80 kilometers an hour, but in the air, 100 knots is 185 kilometers an hour. So you're going to be crossing over terrain much faster than you are on the ground, and in a straight line too. So by spending a bit of time doing map preparation, what you're going to do is you're going to reduce the amount of stress that you're going to experience in the cockpit. You're going to be better prepared, you're going to save time and be more efficient. In flying, they call it keeping ahead of the aircraft. You always want to arrive at your destination 5 minutes before the aircraft does, another old saying. Well, that's the end of part 3. Part 4 will be concerned with the Global Navigation Satellite System, commonly known as the GPS, and different GPS units you can use, and also various apps you can use for your smart devices. After that will be exercise drone search, a bit of information so that you can prepare yourself for your exercise. And I'll see you at part 4. Bye bye.